Hello everyone, I am Manav and in this video we are going to cover the whole chemistry. Yes. In this video we will talk about air, about water. And after that I will also tell you some tricks to make the chemical formulas or like all this stuff. So it's mean that in this video we are gonna cover these three topics in just 15 or 20 minutes. So, without wasting any time, let's begin with the topic that is air, water, and learning about chemical formulas. So I think first we should start with the chemical formulas. Should we? Yes. So let's start with the chemical formulas. I mean, how to write chemical formulas. You know CO2, from where it came? You know? From where it came? Don't. H2O? Don't. I'm gonna tell you all those things in this video. So first I would like to tell you that for this you must be aware about valency. What is valency? You know about electronic configuration? Do you know? Do you know that what is electronic configuration? This topic relates with our atomic structure, or we can say atoms and molecules. So what is electronic configuration? What do you mean by it? First thing, electron configuration. We can, but I think we will not say this because this word does not take any mean or anything you can say. I'm right. So, first, that you must know, electronic configuration is the total number of electrons that are present in an atom of an element. Iron, Fe. What is the electronic configuration? I don't remember. I don't know about periodic table too much. Helium, 2. I mean, there are 2 electrons present in shell's orbital. Hydrogen, how many? 1. Periodic table is also fully setted with the help of electronic configuration. First which we have hydrogen, because it has only one electron. Total electron is 1. And in helium 2. In oxygen it is 8. So what is electronic configuration? The total number of electrons that are present in an atom of an element. Could it make sense? Now, you must be know about the KLMN. I know a lot of the people will say these are the alphabet of English. I know, my dear friend, you will say like this. But KLMN, you are right that these are the alphabets of English. But in chemistry, these are the names of particular shell. K, L, M, N. After N, what we have? P, Q, R, S, T, W, X, Y, Z. All those mean things. But the particular thing, first we have K, then L, then M, then N, then going. there is a limit. There is a limit for particular shell to take or to survive with electrons. Meaning first K, the capacity is 2. Only 2 electron can stay there in the K. And second, I think it is 8. Yes, 8. And after that it is 16. 16, I think. So it has a particular range. And from these two things, we have valency. You must be aware about noble gases. Helium, Hina, Nina, or Karina. I don't remember them in series. Those are, there is He, helium, and after that Annie, and Ar, argon, Kr, axon, and Rn, I think. I don't know that particular, I know the samples, but I don't know the full form. I just know 2, 3. So the noble gases are what? The gases that don't talk, or we can say they don't talk with others without any task. If they don't have any work, so then don't talk with others. At the right, very right side of the F block, I think. Yes, I think F block. At the very right side, noble gases are situated in the periodic table. So those noble gases are too much stable. When they are stable, we can say comfortable. For the human beings, what is the thing that can make them comfortable on earth? Money, salary, house, and whatever, all those things. But first, money, family, like those things. All these things are already been given to noble gases by the God. How they mean stable? Mean in our chemistry we cannot say they have too much money. How they are stable? To be stable, to an element to be stable in chemistry, it must have 8. It must have 8 electron in its outermost shell. Helium. Oh, not yes, in the outermost shell. It's valence. I cannot remember that thing. What I would like to say is, yes, it must have 8 electrons. Now, what is valency? The valency tells us that how many electrons are needed. If there are 2 electrons, so it is stable. It is stable. Not it is not stable. So how many electrons are needed? 6. We know the maths, a little math here. So, valency. What is valency of oxygen? Wait a second. In my oxygen. Yes. The valency is first 2, then 6. Mean 2 are needed. 2 are needed. Who will give you any other element? So 2 is the valency of oxygen. Carbon valency is 4, and I think it is its valency is 4. Yes. So now we will write C. I am just telling you the formula of carbon and oxygen, mean carbon dioxide. C. Write its valency 4. Oxygen, its valency 2. Crisscross method, mean like this cut, like this cut. With C we get 2C2O4. We can easily divide it. Here at the C it become 1, and at the O it become 4. 2. And when it became 2, we get the formula final. We got the formula. Hydrogen, water, H2O. In H2O, the our valency is 1. Whenever your electronic configuration is lesser than 4, so its valency will be that particular number, that is the electronic configuration of that particular element. So in our hydrogen 1, oxygen 2, H2O1. You don't have to you don't have to write that one. It's not like too much compulsion to write. You must have studied exponents and power chapter in mathematics. Power, raised to the power. So when there is one power, when the power is 1, so we don't write. So it's no need to write in chemistry also. Okay, ji. Now, shall we move to air? Air is where? Everywhere. But there is exception, and you know that exception, you'll have to face exception in chemistry. Because chemistry without exception is nothing. So you'll have to face exception. Air is everywhere, leaving vacuum. Air is also here, everywhere, leaving vacuum. And where is vacuum? The vacuum is there, where no substance can survive, where no particle is there. The place where no particle is there is what? Nothing but a vacuum. What? Vacuum. So this air in earth, on the earth, consists of many gases. Many. How many? Many. The most abundant gas here is carbon dioxide, or lesser than carbon dioxide there is argon and other. In the flow chart or in the pie chart of the gases, you must have seen that thing. Most gas, one gas is too much. Nitrogen. But nitrogen is not useful because plant cannot use it directly. So plant have a symbolic relation with the other microorganism that make that particular nitrogen and change it to usable form, and then plant give them food to that organism, and this relationship works, and the plant get its nitrogen for its benefit. I don't know why they use it. 71% of the gas in the air is nitrogen. On the second number, we have oxygen, the essential gas. Without oxygen, we cannot live. Very, very, very important. Or are you from Mars? Do you breathe with carbon dioxide? No. No. Oxygen is 21%. After that, carbon dioxide, I think 0.3%, like this. But it is not too much in air. Some days ago, Ozone Day was celebrated. I don't know people celebrated it or not. But our teacher told us about the ozone layer. Ozone layer. The layer that protects us from UV rays or ultraviolet rays. Of Mars? No. Of Sun. What the researchers had found, they found that there are some holes in the particular ozone layer, and that can work as harmful thing for human being. So please stay at your home, but go to your school. So why that there is a hole found in ozone layer? Due to of air pollution. Not of air pollution, there is a gas. There is a gas, chlorofluoric gas, like this is the name of that particular gas, that released from the perfumes. And that is too much harmful for the ozone layer because it cannot survive in that particular gas. So I hope, friend, you understand our today's topic. I am ending this video now. Thank you.